Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So today, once again, I'm going to show you that it was I who revealed the correct fundamental theorem of calculus. So just to show you that I'm correct and that there is confirmation of what I'm telling you, I'm going to go through this temporary chat. So I asked ChatGPT who was the first to realize that the mean value theorem is the fundamental theorem of calculus. That is, that the fundamental theorem of calculus is obtained in one step from the mean value theorem. So ChatGPT comes back and says it was Cauchy who made the connection explicit in his course d'analyse. He recognized the mean value theorem as a central tool, blah, blah, blah. And then I said, show me the source text exactly. And then, of course, because there isn't, it comes back and says, I couldn't locate a passage in Cauchy that says the FTC follows in one step from the MBT. I checked the translation and original text, but found no explicit statement phrased that way. If you like, I can try to find the closest statement. My response then is, so it was not Cauchy then. And then the feedback is correct. Cauchy never explicitly stated that the fundamental theorem of calculus follows in one step from the mean value theorem. Blah, blah, blah. Then again, it does another search and it doesn't find a credible source that clearly identifies who first articulated that idea. Before we continue, by the way, it was I who articulated that idea. Okay, I was the first. And then it says no historical text asserts that formulation explicitly. So then it tells me, can I try again to find more information? I'll say go ahead. Thinks for 7 seconds and it says there is no single clearly documented person who explicitly wrote the FTC follows in one step from the MBT. That's obviously a lie because I have written that, but because I have been excommunicated from the corrupt mainstream cabal of mathematics, you obviously won't get to know that, okay? So, but now you will know it because I'm telling you. Now, so I said again, show me just one instance where the authors routinely present the FTC as an immediate corollary, because that's what it tried to imply. And it says, oh yeah, this particular book here, Teaching the Fundamental Theorem of Calculus. Well, I get to the point and I say, show me a source or admit there isn't any. And it says, you are right to press for precision. And then it says, most modern texts do this by directly considering that. So the honest answer, so now we get to the honest answer. No such explicit source exists. The FTC in one step from the MBT is a later interpretation, not found in Barrow, Newton, Cauchy, or any standard books. I made that claim. That's why there isn't any other source available. Okay? So it's incredible how stupid and how arrogant and how intellectually bankrupt the mainstream math cabal is. As an exercise, I will put this article in the details section to show you why my claim is true, that the mean value theorem is the fundamental theorem of calculus. And you can read through this and study it on your own. But as a final as a final conclusion to this video, I'm going to play a podcast for you. And then I'm going to sign off. So if you're not a red subscriber, please become one. Click like, follow me on academia.edu. Till next time, I'm John Gabriel. Here's the podcast.
Welcome back to In-Depth. I'm Richard Price, founder and CEO of academia.edu, and today, oh wow, we have a truly thought-provoking discussion ahead. As always, I'll be walking us through the ideas presented in a recent academic paper, and just to remind everyone, I'm presenting these ideas neutrally, not endorsing or rejecting them. Remember, academic research isn't a verdict, it's an ongoing conversation. Okay, let's dive in. The spotlight's on a paper by John
So what he just said there is a load of rubbish. What I'm telling you in this article isn't research, it's fact, and it's indisputable, and it's not up for debate. Let's continue.
Gabriel, and if you haven't come across his writing before, well, let's just say he does not mince words. The title itself is pretty spicy. Mainstream mathematics academics are arrogant and incorrigible ignoramuses. The mean value theorem is the fundamental theorem of calculus. Quite a mouthful, right? But don't be thrown off by the colourful language. Our focus is the argument, not the attitude. So, what's the core issue John Gabriel tackles? At its heart, he asks, what really is the fundamental theorem of calculus? Now, if you've taken any calculus courses, you've heard about both the mean value theorem and the fundamental theorem of calculus. Gabriel, however, claims that the mean value theorem is the fundamental theorem, that the difference between them is basically artificial, or perhaps superficial. Why is this a big deal? Well, if true, it could change how we teach and understand the very foundation of calculus, right? Students, teachers, everyone might need to look at calculus in a new way. So let me try to summarize Gabriel's main arguments and findings as neutrally as possible. He starts by stating very directly that, in his view, mainstream mathematicians fail to see that many theorems, like the average value theorem, the mean value theorem for integrals, and even the fundamental theorem of calculus, are really just variations of the same basic result. That result, according to Gabriel, is what we call the mean value theorem. Let's talk about what the mean value theorem actually says. For any smooth function, there must be some point c in the interval from a to b, where the slope of the tangent at c matches the average slope from a to b.
That's not what the remarkable statement of the mean value theorem says. It says that the arithmetic mean of the y-coordinates of the derivative is given by the finite difference of the primitive function, where you take the boundary values difference and divide it by the interval length. Let's continue.
Formally, that's written as fc, e.g. fb, fa, it, b-day. Gabriel goes further, though. He asserts that the fundamental theorem of calculus, usually stated as ab, fx, dx, it, fb, fa, is just a restatement of this same underlying principle. His reasoning? If you look at the definition of an integral, it's just the product of the average value of a function and the width of an interval. When the function is a derivative, it's the mean value theorem for that derivative.
If the function is not a derivative, you can't use calculus at all, okay? You can't use the fundamental theorem, because the fundamental theorem requires that you have a primitive and a derivative. If you do not have a primitive function, then you resort to something called numeric integration. Let's continue.
Well, it kind of circles back on itself, huh? A main tangible insight here is that, from Gabriel's angle, many foundational theorems students struggle to connect, like the average value theorem, which says the mean value of a function exists on the interval. The mean value theorem and the fundamental theorem are fundamentally the same insight in disguise. So if that's true, it could, in theory, simplify how instructors introduce these concepts and help students see calculus as more interconnected, a web rather than a pile of disconnected facts. Now, what about the methods or proof? Gabriel references providing constructive proofs, both using what he calls flawed mainstream calculus and his new calculus system. I have to be super clear here, just reminding everyone again, these are his terms, and the new calculus is not widely accepted or adopted, but he claims that both approaches lead to the same conclusion, that the mean value theorem deeply underpins the mechanics of integration and differentiation. A quick digression here. Does anyone remember when they first had that aha moment about the mean value theorem? I, for one, totally misunderstood it in undergrad. I kept thinking it was only about speed limits, like, you drove 60 miles an hour, so at some point you had to be going exactly 60 miles an hour. That's a classic example. But when you dig into the math, it's so much richer, right? Anyway, back to the paper. One of Gabriel's recurring themes is that academic research, and this applies to all areas, not just mathematics in my view, is a conversation, not a declaration of gospel truth. Even his most strongly worded critiques are a prompt to re-examine familiar things, not just accept or reject outright. For you, the listener, what does it mean? Maybe next time you come across a concept that seems like a just memorize this kind of fact, take that as a cue to dig for the underlying connection. Maybe the surface differences are less important than the unity underneath. Just to repeat for clarity, I'm presenting Gabriel's arguments, not advocating for them. Most of the mathematical world doesn't agree with these statements, but engaging with challenging or even aggravating perspectives can be productive. As always, peer review, debate, and a healthy skepticism are the lifeblood of academia. So,
So peer review is really a load of rubbish because in order to have your work reviewed by peers, they need to at least have the same content knowledge as you do and also a very close level of intelligence. So yes, it is important to look deep at these things because what you're told is just simply the wind that comes out of these idiotic professors' mouths who have never understood calculus. Um, it's not a case of me just saying these things as opinion. I'm stating these as an authority. No, my authority does not come from the mainstream. It comes from fact and reason. That's my only source of authority. Okay, and peer review doesn't make mathematics correct. Many articles are published, many books are published, and they've been peer reviewed, and they're a bunch of rubbish. So let's see if he has anything further to say.
wrapping up, whatever your experience with calculus, this paper is a reminder that the process of mathematics, and really all research, is alive. Each theorem is a stepping stone, not an endpoint. Maybe next time you see a theorem, ask yourself, is this truly a new idea or a new flavor of an old one?
Okay, so that's pretty much it. Till next time, I'm John Gabriel, and this is a New Calculus channel. Remember to subscribe and click like. Goodbye.